Thank you for joining me today. We started on Tuesday how to measure the quantity takeoff of wood construction. To be honest with you, we have three techniques to measure the wood construction. The first one, we can measure the lumber volume or lumber quantity takeoff using the unit broad foot or broad measure. The second technique, I'm sorry, not broad board. The second technique is the unit or linear lens. The third technique is the area. We will go through all of them one more time today. Board foot or board measure is a unit that will be used to measure the volume of the used lumber. Board measure looks like one board measure or one board foot is a piece of wood in these dimensions. 1 feet by 1 feet by 1 inch thickness. This is the meaning of one board foot or one board measure. Is defined as a piece of lumber or piece of wood 1 inch thick by 1 foot wide by 1 foot long, or its equivalent. Does that make sense? So if you would like to convert a piece of lumber to how much board foot or how much board measure, you need to multiply the length of this piece in foot by the nominal width and the nominal thickness. Keep in your mind, for any lumber piece, we have this cross section. One of them is called width, one of them called the thickness, and typically they are given in inch. If you multiply these two dimensions by the length of the piece in foot, you can convert how much board foot, how much board measure for this piece of lumber. If you have many pieces, like 14 pieces, then I will multiply by 14. If you have 20 pieces, then I will multiply by 20. If you have 19 pieces, then I will multiply by 90. So in this wood construction, we have this lumber or this lumber or this one. We can figure out how much board foot or how much board measure to construct this kind of element. It's very easy. This member has a cross section, width in inch and the thickness in inch. If you multiply both of them by the length of this piece, you can convert this piece to how much board foot or how much board measure. Both of them the same. Then you need to multiply this amount by how many pieces do you have. As you see in this photo, this pieces is repeated many times. So how many? And we started this example last meeting, and also we decided that if you have different types of lumbers, sometimes your lumber are used as studs, sometimes they are used as joists, sometimes like rafters, sometimes like ridges, sometimes like purlins. All of them may be the same meaning, but in different use. If you look to this construction, this is a lumber. used as studs. Studs are the vertical element. All of these vertical elements are called studs. This one is lumber, also used as joists. They are not seen from here, but we have horizontal member like this one. This piece is called joist. This one is joist. We have this inclined lumber in a sloped direction is called rafter. This one is called rafter. This one is called rafter. If you have different use, if you have different categories, we need to figure out the quantity take off for each alone separately. So lumber for framing shall be classified and measured separately in the following categories. Does that make sense? And we covered this last meeting. This example, I would like to repeat it one more time. We are given the framing system for your building. This framing system consists of studs. These studs or these studs are 2" by 4", and the length for each piece, this piece has a total length equal 10 feet. So the board foot for the studs equal. The cross section is given 2 by 4". The length of this piece of one piece 10 feet divided by 12. This is how to convert one piece to board foot. The two thickness in inch, the two dimension, in inch, width and thickness by the total length in feet divided by 12. And this stud or this piece is repeated many times. If you can see, we have 1, 2, 3, 4, 5. We can say 4 in this side. I will not count this one. 4 this side. From this side, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have 10 on the other side. So we have 10 here, we have 10 here, we have 4 here, so the total will be 24. So I will multiply this number by 24. This is the number of pieces. Then you can find out the quantity take off for just studs, only studs. So 2 by 4 by 10 divided by 12. This is for one piece, times 24. The total is 160 board foot. And we are given the cost, $1.25 for each board foot. So the cost for studs only will be 160, the total board foot by $1.25. Then I can find out the cost for studs only $200. This point is very important. You have to expect something like this in your coming exam. But probably I will give you some information in a different way. I will not give you this sketch, maybe in different way to figure out how many studs. Does that make sense? For example, for joists, the joists are 2 by 6, 2" by 6", and the length for one piece, equal 20 feet. So for joists, I can say the board foot equal 2 by 6 by 20 divided by 12. This is how much board foot for one piece. This is inch, this is inch, this is feet, divided by 12. How many? You need to look to the sketch and figure out how many pieces of joists. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces for the joist on the floor. So I can say 2 by 6 by 20 divided by 12. This is for one piece, times 10 for the whole, all of them, equal 200 board foot. So the cost for joists, for each one board foot, we have a cost 1.75. So 200 times $1.75, the cost will be $350. That makes sense? For the last one, for the rafters, by the way, the name will be given. Don't worry. It's not it's not a wood construction course. It's just cost estimating. So I will give you the names for these parts. Don't worry. We have here rafters. This piece has a cross section 3" by 6" and the length equal 15. So for rafter, how much board foot? Equal, you said 3 by 6 by 15. 3" by 6" by 15 feet divided by 12. This is how much board foot in one piece. How many pieces do we have? I think we have 20. 10 from this side and another 10 on the other side. So it will be 20 pieces. So the total board foot will be 3 by 6 by 15 divided by 12 times 20. I got 450 board foot. The cost for one board foot equal 1.95. So the total cost will equal 450 times $1.95. It will be $877.5. So the total cost to construct this roof equal the cost for studs, $200, plus the cost for joists, $350, plus the cost for rafters equal $877.5. Equal 1,427.5. So if you go to Lowe's or Home Depot, you have to pay $1,427.5 just only for material, just only for buying the studs 20 piece, 24 piece, and joists 10 pieces, and rafters 20 pieces just only for material. Any question about this point? I repeated this example one more time because it's very important. It's very important. And keep in your mind, if we have different categories for the lumber, all of them are lumbers, but in a different size. If you have different categories, we have to consider each alone, because as you see, the cost for each is different. You need to find the cost for each alone, or the quantity take off for each alone, and then by the end you can add the total cost together. That's fine. Keep in your mind, sometimes we have composite cross section. Composite section. What do you mean by composite section? It's not in the real life, I'm sorry, it's not natural to have a cross section looks like this, but we have different pieces. I have a piece like this. I have another piece like this. And I have another piece looks like this. These pieces are connected together to create a I section. In this case, we are not using the board foot or board measure as a volume. No, we are going to use linear foot. So how long for these pieces? Because the cost will be around, for example, $100 for 1 foot. Does that make sense? So we need to figure out how many foot, or what is the total length for this kind of wood members. So for example, I'm giving you this floor and I'm telling you, hey, the cost for this joist equal $100 for each foot. That means you need to tell me what is the total length. So what is the length for this piece? For example, 20 feet. And this piece is repeated many times. 1, 2, 3, 4, 5, 6. And we have another 6 here. So the total is 12. And each is 20 feet. So the total will be 240 feet. 240 feet. The cost for 1 feet equal $100. So you need to multiply 240 feet by $100. You can get the total cost. So sometimes the manufactured beam, what you mean by manufactured beams, they are not in the natural. Like this piece, this lumber is coming from the tree directly. But for this one, no, we need to refabricate it. We need to remanufacture it. That makes sense? So we have a piece, another piece, different piece, fabricated together or erected together to create this member. In this case, we are going to use the linear measurement, linear foot or linear meter, whatever. And the cost will be per linear foot, 1 foot. So in this case, I'm going to measure the length, the total length for these members. I have another example here, which is a very good example. This example was one of the problems in the exam for last year. We are given a truss. I think you are familiar with the truss. What is the meaning of truss? You learned this in different courses. You learned this in building construction last semester and engineering mechanics. Truss means we have members. These members are connected together. Does that make sense? So we have a truss here. This truss is connected together, like maybe like this one. This is a truss. We have a member, we have a member, we have a member, we have a member. So these members are connected together and you can see the connection. We have bolted connection here, a technique that can be used to connect these members together. Okay, so one member of this truss has a cross section equal 3 inch by 3 inch. Looks like we have a cross section of the wood, and this is a one piece or one member. Looks like this, 3 inch by 3 inch. If you look to the member, we have a member with cross section. And this wooden roof truss are spaced at 20 feet. As you see, if you watched a construction for a building before, this truss is used for the roof system, and this truss is repeated at equal spacing. This truss, as it is, this triangle, as it is repeated many times. Based on the given information, this truss is repeated every 20 feet. And this truss is repeated every 20 feet along the length of the building equal to 100 feet. So the total length of the building is 200 feet. I repeated this truss at equal spacing 20 feet. So anybody can tell me how many truss do you have?
It would be 20 plus 1 on each end. So maybe 21 or 22.
It will be what?
21.
21. So how did you know this? One more time. One more time. The length of the building, the total length of this building is 200 feet. I repeated the truss every 20 feet. So do you think
I'm sorry, 11, not 21.
it's 11, not 21? It's 11. If you divided 200, the total length, by the spacing between trusses, which is 20, equal 10 spacing. So the number of spacing between the trusses equal 200 divided by 20 equal 10 spacing. But 10 spacing, I will start with a truss and I will end it with another one. So the number of spacing plus 1 can give you the number of trusses. This is just information, the total number of trusses. If you'd like to repeat it one more time, we have a truss, looks like a triangle. This truss is repeated one more time after 20 feet with another truss. After 20 feet, we have another truss. After 20 feet, we have another truss. This will be repeated for the total length of 200 feet. So I will have 10 spacing, each spacing 20 feet. So that means, because the last one will be a truss, so the number of trusses equal the number of spacing plus 1. So we will have 11 trusses. So let's start to talk about one truss. For one truss, only one truss. This truss looks like this. The given dimensions, 8 feet, 16 feet. 8 feet, 8 feet, 8 feet, 8 feet, and this one 16 means we have 8 and 8. The cross section for one member is 3 by 3. Is it correct? 3 by 3, yes. 3 by 3. I would like to figure out how much board foot for one truss. It will be 3 feet, 3 inch by 3 inch by divide 12 by the total length of the truss members. What is the length of this member? 8. What is the length of this member? 8 feet. What is the length of this member? 8 feet. What is the length of this member? 8 feet. What is the length of this member? 16 feet. What is the length of this member? 8 feet. What is the length of this member? 8 feet. What is the length of this member? I don't know. We can find it out using right angle triangle. 8 square plus 8 square under square root. I got 11.3. This one will be 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 11.3 feet. So I can say the total length of the truss members will equal 8 feet repeated how many? 1, 2, 3, 4, 5, 6. 6 times. 16 feet times 1 member only. 11.3 feet times how many members? 1, 2, 3, 4, 5, 6 times. I think we are done. So the total length of the truss members, 8 by 6 plus 16 plus 11.3 times 6, I got 131.8 feet total length. So I need 131.8 feet of lumber just only to construct only one truss. So the board foot for one truss will be 3 by 3. This is the cross section for one piece, time total length, which is 131.8 feet divided by 12. So the board foot will be 3 by 3 divided 12. I got here 98.85 board foot. This is only for one truss. Remember, we have 11 trusses. So board foot total will equal the number of trusses 11 time the board foot for one truss 98.85. So the total will be 1087.35 board foot to construct only these trusses. That makes sense? That makes sense? So what I did, I calculated how much board foot for one truss, how the cross section for one piece, 3 inch by 3 inch, given by the information here, 3 by 3. And what is the length for each member? What is the length of each member? Each member, I added them together to find out the total length of the truss members. Multiplied by 3 by 3 divided by 12. This is the board foot for one truss. One truss only. One truss. Since we have 11 trusses to construct the whole roof, I multiplied 11 trusses by board foot for one truss to find out the board foot for all of them. Does that make sense? This is a very good example. We have here the cost for lumber. It's equal, not 500, it's 0.5 $0.5, not 500, I'm sorry. 500 is too much. For each board foot. Do you know why it's too much? Doesn't make sense to pay $500 for just this piece. This piece is cost me $0.5. Does that make sense? This is the cost for each board foot. This is board foot or board measure. So $0.5, that makes sense, not 500. So if you are given the cost for board foot, I can multiply the cost will be $0.5 time 1087.35. So the total cost will be $543.6. Just only as a material, only material to buy the material wood as a material for trusses. Just the material. I did not talk about the connection. I did not talk about the worker. I did not talk about the bolts. I did not talk about anything else, just the material to construct the whole trusses. Do you have any questions so far? Guys, do you have any question?
No, sir.
I do recommend to pay more attention for this example for truss, because you should expect one like this in your coming exam. And make sure 3 by 3 cross section is used for all members. Because sometimes, maybe, nobody knows, I will give you a truss. Maybe it's the same truss. But this member is 3 by 3. And this member is 4 by 4. And this member is 5 by 5. You know what I mean? The cross section is different. The cross section is different. The cross section is different. So if you would like to figure out the board foot, the board foot, I'm sorry, you need to consider each members alone. So these members plus these members plus these members. So you need to multiply 3 by 3 by lengths of these members divided by 12. These members will be 4 by 4 by the lengths of these members divided by 12. These members will be 5 by 5 time lengths of these members divided by 12 to find out the total board foot for one truss. Why you did this? Because the cross section for each member is different. We did not do this for this example because the whole members had the same cross section. So I multiplied 3 by 3 for the total length of these members. That makes sense? So just pay attention for this kind of examples. Sometimes we are measuring the wood using area for sheathing. If you would like to cover the front elevation of your building, or if you would like to make sheathing for the roof after you construct your truss, we will do sheathing. So in this case, we are going to use a different material or roof sheathing or plywood sheets. We are going to use sheets. These sheets are measured in area, square feet, or maybe square meters. Does that make sense? So this sheet is measured in area, not board foot, not linear foot, but in area, square feet. So if you would like to figure out how much sheets I need, you have to figure out what is the total surface area for this front of your house. We have example here on this point. We have a customer would like a bonus room to be added to an existing home. So he has existing home and he would like to build a new room. The new room is to be 26 by 24 with an 8 feet ceiling height. So looks like I can draw it here. The room looks like this. It's very important to imagine. So looks like this one will be 24 feet and this one will be 26 feet. And the height of this room is 8 feet, the height of the ceiling. And we have something here called the 2 feet roof overhang. If you look to this roof, we are constructing the roof looks like this. Can you see it? This is the final shape of the new room. 24 by 26 by 8 feet height. The height is measured from here to here. Then I will construct the roof with 2 feet roof overhang. Roof overhang means the roof is extended here with 2 feet. Is extended here with 2 feet. That makes sense? If you cannot imagine, just look to this side. This is the back of the room. If you look to the back, we have this 24 by 8. And then we have the shape of the roof. And this part is called overhang. The ridge of the roof, this is the ridge. This line is called the ridge of the room or the roof. is be centered over the 24 foot wall and is 5 feet above the top. So this ridge at 5 feet at the top of the wall. If you look to this given sketch, we have here 5 feet. Assuming the builder uses standard 4 feet by 8 feet plywood sheets, these sheets are available in Lowe's or Home Depot. We need to determine how many sheets we need to order to cover the walls. First, we need to start with the walls. We will not account for doors or windows. Don't account because we are not given any information about the doors or windows. Just to cover the walls. This is a wall. This is a wall. We have another wall on the back and on the other side. So let's start with the walls. I will start with the walls. What is the total surface area of the walls? Guys, keep in your mind, your room looks like this. I don't care about the ceiling. I'm sorry, about the roof. So we have 24. We have 26. And your roof looks like this. Let's start with the first wall. This wall. What is the area of this wall? Anybody can tell me what is the area of this wall? This one.
It's 24 by 8, which is 192.
It's a good point, but I think this part is considered as a part of the wall. Do you agree?
Oh, yeah, then you would add 5 by
Yeah,
12.
we need to add this triangle. The shape of the first wall, which has this shape, it looks like a rectangle plus this little triangle. This is a whole wall. Does that make sense? So the area of this wall, I think area 1 will be 24 by 8 because this side is 24 and this height is 8. I need to add 1/2 times 24 times 5. I'm sorry, what do you mean? You said it's a triangle. Yes, it's a triangle. The length, the base of this triangle is 24. The height of this triangle is 5 feet. The area of this triangle 1/2 times 24 times 5. That makes sense? And keep in your mind, this wall is repeated 2 times. From this side and from the other side. Plus, the area of the wall in this side is only just 26 by 8. Yes, it's 26 by 8 only. No additional part, no triangles, nothing. And this wall is repeated one more time from this side, so I need to multiply it by 2. If you can find the total number, this is the total surface area of the wall. Is it correct or not? Let me find first the area. 28 times 8 plus 1/2 times 24 times 5 times 2 plus 26 times 8 times 2. 920 square feet. Is it correct? Or I need to do something else? I need to order 920 square feet of the plywood to construct the wall. I think I need to multiply this whole number by 2. I think it will be 1,840 square feet. Do you know why? I think if you would like to cover a wall by plywood, you need to cover the wall from this side and the other side. Let me draw it here. I have a lumber, looks like this. And this lumber is repeated, which are the cold studs to construct your wall. These are the studs in one wall. If you would like to complete the construction of this wall, I will put plywood from this side. And I need to put also plywood from the other side to construct your wall. Does that make sense? So I need sheets from one side, this side of the wall, and another sheet from the other side of the same wall. So since this value, which is 920, is the total surface area of the wall from one side only, from the outer side of the building, of the wall, of the room, then I need to multiply this total surface area by 2, because we are double the surface area to put plywood sheets from both sides. Guys, did you understand this point? Is it clear for you?
Yeah, it makes sense.
One more time, you have a wall. This wall is 26 by 8. If you would like to order plywood for this wall, it's not only 26 by 8 and that's it. No, 28 by 6. This is only the surface area for the plywood from this side. This side of the wall. We have another side on the interior, inside the room. So we have another side with the same area. So if you multiply 26 by 8, you have to double it, this area, for the same wall. So what I did right now, 24 by 8 plus this triangle, just only one side of this wall, one side. 26, and I multiplied it by 2, because I have another wall. This 2, because I have 2 walls. I have another wall, 26 by 8. This is the one side from this wall. I multiplied it by 2 because I have 2 walls. Then the whole number is multiplied by 2 because I have 2 sides for each wall. So the total surface area will be 1,840 square feet. So how many sheets we need to order? Number of sheets we need to order. The total surface is 1,840 square feet. This total surface area will be divided by the surface area of one sheet. One sheet will give you an area 4 by 8. If you divided the total surface area by the area of one sheet, you can get 57.5 sheets. Actually, I will not order half a sheet, so I will order 58 sheets. So right now, I will call Lowe's to order, hey, I need to order 58 sheets. Each is 4 by 8 feet. That makes sense? Just only 4 walls to construct your walls. The second part of the problem, we need to figure out how many plywood sheets needed to cover the roof over the bonus room. This is the roof. In this case, for the roof, actually, we are going to order one side, which is the top. This side only, one side from the top, because the bottom is something else, based on the ceiling construction or whatever, because we have air condition, electricity, and everything. So we will cover only the top of the roof. If you would like to figure out the area of this shape, I can tell you what are the dimensions. I think this side dimension will be 26. What will be the dimension of this side? Part of this side is 2 feet. What about this side? We can figure this out using triangle, because if you look to this triangle, this side will be 12. This height is 5. So I can tell you what is the length of this side. This side will be 25 plus 144 under square root. This side will be 13. Plus this 2, so the total length will be 15. This total length is 15 feet. So the area, sorry. So the area of roof will equal 26 by 15 times 2. 26, this is the total length. 15, this is the length in this side. So the area is 15 by 26. This is the area for one side of the roof. We have another side. This one. This is the reason why I multiplied it by 2. Keep in your mind, just to give you a hint. This is the shape of your roof. Looks like this. This length is 15. This length is 26. So the area of one side here is 15 by 26. We have another side, so I multiplied it by 2. I can give you the total area equals 780 square feet. So the number of sheets required to construct this roof equals 780 square feet divided by 4 by 8, one sheet. It will be around 25 sheets. So we need to order 25 sheets to construct this roof, and we need to order 58 sheets to construct the walls of this building. Just only, not building, it's only just a room. Does that make sense? So what I said today, the same like I started with. Your road construction can be measured as an area. If you are working with sheets, playwoods, or sheathing for your building, sometimes we can measure it in linear foot length, just length. What is the total length of these members? If you have composite, if you have prefabricated cross section, or we can use board foot or board measure to figure out the lumber of the building. So based on the situation, we can decide which scenario we are going to use.